What's going on, guys? In this video, we're going to be building a serverless REST API using AWS's serverless stack. Now, the AWS serverless stack is going to be made up of three main components. We're going to have DynamoDb for our database to store all of our data. We're going to have our API gateway, and we're going to have Lambda functions. And the app that we're going to make is a simple expense tracker. So this is just going to keep track of our various expenses. And so the way that our app works is we're going to be performing all of the various CRUD operations. So if we send a get method to the /expenses URL and hit send right here in Postman, we'll change that to JSON. You can see it's going to retrieve all of our expenses from our database. And an expense is just going to contain an ID, a description, and an amount. And then if we go and grab, we can grab an individual expense. So if I just copy this ID right here, paste that in there, do a send, you're going to see that we now get the specific item that we searched for. So that's going to cover the get operations. We can also create a new expense. So if we do a post, we can see that we've now created a new expense. And then we finally have the patch, actually the put and the delete operations. So if we go to put and then go into that, and then let's just grab this ID right here. We can update it real quick. And I'm just going to change the amount to 44. Actually, I'll change it to 50. We hit send. And so now we can see that we've updated the amount to 50. And then finally, we can do a delete. And if I just leave the same exact ID, we can delete this entry. So we'll do a send. We'll get a 204. And if we go back and do a get request for all of our expenses, we should see that it's gone. And let's do a JSON. And yeah, it should be gone. Just trust me, I guess. All right, guys. So that's pretty much our application. So in the next video, I'm going to break down what each of the different services do and what their role is in our overall application. In this app, we're going to make use of three AWS services. The first one is going to be DynamoDb. And so that's going to be our database, and that's going to be where we store all of our expenses. Then we have Lambda and API gateway. And if you don't know what either of those do, I think the best way to explain it is to show you an example of what a typical route looks like in an Express application. And if you aren't familiar with Express, if you've worked with any backend language or framework or web framework, they're going to have a concept of routes, so they're all going to be fairly similar. But within a route, there's three different components. The first one is going to be the HTTP method this route is going to handle. So you can see here, this is going to handle get methods, but we would have one for post, we'd have one for put, we'd have one for patch and delete and so on. The second component is going to be the URL. So the user needs to send a get request to this URL to actually hit this route. And then finally, we have a route handler. So the route handler is just nothing more than a function. And that's going to contain all of the logic for when someone sends a GET request to this URL. And the way this maps to our AWS services is that the route handler is just a Lambda function. So a Lambda function is nothing more than just a function. And this function can be triggered based off of various events within your AWS console. And so this is going to take place of the route handler. So this is going to have all of the logic for performing a GET request or post request, or anything like that. So it's going to handle all of the CRUD operations and have all the logic for those. And then we have an API gateway. So an API gateway within AWS, it's going to allow us to basically take an HTTP method and a specific URL, and we could say when we receive that specific HTTP method to this URL, I want you to send it to this Lambda function. Okay, so the API gateway is going to play the role of these two components right here. So it's going to take a like a GET request and a URL, and then it's going to trigger a Lambda function, which is going to be the route handler. And it's really as simple as that. So, working in the cloud with serverless applications, you'll see that all of the concepts are going to map pretty much equivalently to what we do with a specific within a specific node or Express application. The first thing that we need to do for this application is ensure that our Lambda functions have all of the necessary permissions to perform all of the various tasks in our application. So let's go to the Identity and Access Management section of AWS, and that's going to be called IAM. We'll select that. And here we want to define a new role for our Lambda functions. And we'll select create role. I've already got this role. This is the one I used in the demo app. So I'm just going to create a new one with pretty much the same name, but just append the number 2 next to it. So we'll do create role. You want to select AWS service. And then under common use cases, we can select Lambda. Now there's one main permission that we need to add. So that's going to be AWS Lambda basics. I spelled that wrong. Basics execute. Whoops. This one right here, AWS Lambda basic execution role. We'll select that. Second one, if you want some extra logging and things like that for troubleshooting, we can also do AWS X-ray daemon. So X-ray daemon write access. So we'll select that. So once you got those two selected, we can go to the next page. We don't need to assign any tags. We'll go to review. Let's give it a name. So I'm just going to call this Lambda function. Actually, I'll call this Lambda expense role 2. And the reason I'm calling it 2 is because I already have one already called that for the demo app. But if you guys are following along, you don't need to have the 2. You can call it whatever you want. Okay, so we've got this role. So now that we have the necessary permissions, let's go ahead and define our first Lambda function. To create our first Lambda function, we need to navigate to the Lambda section of the AWS console. So we can just do a search for Lambda. It's going to take us there. And within here, we want to create a new function. And we want to select author from scratch. And we need to give our function a name. And I'm going to call this expense-getAll. So we're going to have a Lambda function for each of the various CRUD operations. And this one is going to be responsible for getting all of our expenses. I'll do expense-getAll. I'm going to put a 2 because I already have one that's called getAll. Expense-getAll. So I just want to make sure that this is different. Now, under permissions, we're going to select use an existing role, and we're going to select the role that we just created. So that's going to give our Lambda function all of the necessary permissions to perform any task that it needs to, or most of the tasks. We'll select create function, and that's going to take us to our function page. So we've now created our first Lambda function, and you'll see that there's a couple of different sections on this page. The first section is the designer page. So this is kind of a little GUI where we can, create different triggers for our Lambda functions. We're not going to mess around with this section too much. Instead, I want to scroll down a little bit more, and we can take a look at the boilerplate code that AWS gave us for this Lambda function. And so what we do is we're starting out with an index.js file, and within this file, there's one function, this handler function right here, that's getting one event object passed in, and all it's really doing is it's sending an HTTP response. It's going to send it with a response of 200, and then in the body, it's going to say hello from Lambda. It's a very simple function. There's no logic behind it. All it's doing is just saying hello from Lambda. Now, this event object, it's going to contain information about the actual event that triggered this Lambda function. And so if this Lambda function was triggered because someone sent a request to an API gateway, then that event object is going to have information about that HTTP request, like what were the URL parameters, what were the headers, and what was the body and things like that. Now, since this is going to be our getAll method, I'm going to change this, and I'm going to just type in getAll, or let's getting all records. And if you make any changes, you want to make sure you hit save right here. All right, and so we're going to keep our function looking exactly like this for now. And I want to go and set up our API gateway so that we can actually trigger this Lambda function. To create our API gateway, let's go to the services section and let's search for API gateway. And now within here, we want to select create API. And we have two different options when it comes to creating an API in AWS. We have HTTP API and REST API. The only difference between the two is that the REST API has some more features. It's a little bit more feature rich. It's also more expensive to use as well. But for everything that we need to do for this application, and I think for most applications, the HTTP API can handle it. If you're unsure of which one you should use for a specific project, I recommend you check out this page right here. And it's going to tell you the differences between the two, and it's going to have these nice little diagrams explaining what features are in each one of them. All right, so let's select build under HTTP API. And let's give our API name. So I'm going to call this expenses So I'm going to call this expenses 2. You can just call it expenses. I have to do 2 because I already have one called expenses. And we can ignore this. Just keep hitting next. Here we have to create a default stage. So stages, they're just basically different uh, environments within your application. So if you wanted to have a production environment, a development environment, and a staging environment, you can keep all of those environments separately so that you can perform testing in one and not impact the other. So just leave this as default, and auto deploy is already selected. So if we ever make any changes, it's going to automatically deploy those changes. And then here we can select next. And then this is just allows us to review all of the settings that we've set. We'll hit create. And this is going to be our new API. And the first thing that we have to do is under routes, we need to actually define our routes. And we're going to create a new route. And you'll see how familiar this looks to a typical express route, right? So here we specify the HTTP method. So we want a get method, but we have all of the other HTTP methods at our disposal, as well as an any if you just want to match all of them. And then the specific URL that the user has to navigate to. So here we want them to go to expenses. We'll hit create. And so now we've got this get method under /expenses, and we need to attach an integration. And what that means is we're just going to assign a Lambda function whenever someone sends a get request to the /expenses API, expenses URL. So we'll do attach integration, create and attach an integration, and then we want to select Lambda function. Select whatever region you created your Lambda function is. I recommend if you're following along, just set it to US East 1, even if it's not the closest one, just so that you can have everything match up to what I'm doing. And then within this dropdown, we should be able to select which Lambda function we want to trigger. So I'm going to do expense-get all to. You can leave everything else the same. We'll do create. And now we've got our Lambda function associated with this get request. Now, how do we actually send a request to this API endpoint, right? Because all this is /expenses. That's obviously not a valid URL that we can navigate to in our web browser. Well, if we go to this right here, which is going to take us to the homepage for this specific API gateway, it's going to show us the invoke URL. So this is the URL that our API exists on. So if we copy this and just paste it in here, hit enter, you should see a message not found, which you might think that our API is broken. But if you think about it, look at our routes. Look at how we set them up, right? There's nothing on the /URL. We only have one route under the /expenses URL. So we have to go to /expenses. And at that point, we see getting all records. So there you go, guys. We've successfully created a Lambda function and have set up an API gateway route to trigger that Lambda function. And that's basically how you configure a REST API using Amazon's serverless architecture. Okay, so now that we've set up our first Lambda function and our first route to trigger that Lambda function, let's configure the 4 other Lambda functions that we need. So I'm going to go back. I'm going to search for our Lambda functions page. And I'm going to create a new function. And so this one is going to be called expense-get1. And under permissions, make sure to select the role. Okay, and the only thing that I want to change is just the body for now. So we'll say getting 1 expense. All right, the next one is going to be the create. We'll do expense-create. And here we're just going to send back a created expense. This should technically be a 201 for creating. Next one's going to be expense update. And lastly, we're going to have our delete. I think it deletes status code as 204, but I'm not positive. I always forget, but we'll just leave it as 204. All right. And so we've got all of the basic structure for our Lambda function set. They're obviously not performing any logic or actually performing any actions. But now let's set up all of the routes for the 5 different Lambda functions and just make sure all of those are working. All right. So let's navigate back to our API gateway. And you want to find the API gateway that you created before. So mine's called expenses too. And we're going to go under routes and set up all of the other routes. So we'll do create. We're going to have one for post. So this is for creating an expense. And it's going to be on the slash expenses. I think I did expenses. I can't remember if it was expense or expenses. Hopefully it was expenses. So we'll do create. Yep, it was under expenses. So let's go to post and let's attach an integration. And we want to create and attach an integration and then select our Lambda function. So this one is going to be expenses dash create 2. Okay, so that one's set up. Now we have to set up the get one, the get one, the update, and the delete. Okay, so we'll do get one and we'll call this expenses. Now we have to think about how we set up the URL parameter within AWS, right? Because normally within a Node or Express application, you would specify, a colon ID as the variable. But within AWS, it's a little bit different. Instead, what you have to do is curly braces and then ID. So this is going to pass off that variable to our Lambda function as an ID, as the ID, and so then we can use that as to perform whatever logic we need to. So we'll do create now, and under this get method, we'll do attach integration. You'll see that there's a lot of repetitive work here. So we'll then go to get 1, 2. It's a weird name. So create. And then we want to go back to routes. We'll do our update now. So this is going to be a put. And it's going to be the same thing. We're going to do curly braces and then ID. And then finally, let's knock out our delete. All right, so we've got all of our routes set up. Now let's quickly test our API endpoints just to make sure that all of them are working. And we're going to use Postman for that. And so I'm going to open up Postman real quick. And so let's go down to the main page. Let's copy our URL and let's test out all of the endpoints. So here, expenses, if we do a get, this is going to be the get all. So let's do a send. And then we see getting all records. Great. Then let's do a post. Created expense. Great. Then we want to try a put. And this is going to be with some value. Doesn't really matter what it is now. Updating expense. Great. And then we want, where is it? Delete. Okay. And so you'll see that there's no body, and that's because I think by default, Postman, when it gets a 204, it automatically doesn't show you the body. So that still confirms that it's working because we got the 204. And then finally, we want to do a get as well. So this is going to be the get one URL. And there you go, guys. So we've got the basics of our API endpoint set up. In the next section, we're going to actually have to start building out our database so that we can store our different records. Okay, so to create our DynamoDb database, let's go under the Services tab and search for DynamoDb. And under the dashboard, what we want to do is select Create Table. And you could think of a table in DynamoDB as a table in like a Postgres or a SQL database, or I forget what it's called in a Mongo database, a collection maybe. But this is going to store our expenses. So I'm going to call this expenses. I'm going to have to call it two because I already have one that's called expenses. Feel free to call yours just expenses. And we have to give the partition key. So this is kind of the equivalent of the primary key. So this is the key that's going to ensure that every entry is unique. So we're just going to call this the ID. This is going to store a unique ID for each entry that we put into the database. And we can leave this as a type of string. Now, under the default settings, let's uncheck this. We want to modify one setting, and that's going to be this one right here. So instead of provision, we want on demand. And this is just for pricing purposes. So provisioned just has kind of like a flat fee, I guess. But when you do on demand, you just get paid for all of your specific requests. And since we're just testing, we'll have very few requests. So this will be the cheaper option for you guys. Everything else you can leave default and then hit create. All right. And so once our database has been initialized, we can go under items. And here we can actually create a new entry. So if we do create item, and I like to move into text mode. So it looks like we're just configuring basic JSON. It's a little bit easier to read. I mean, if you look at this, I don't know why. I just don't like it. But for an ID, let's just create our first entry. We'll just give it an ID of 1. We'll give the description. And this is going to be for, let's say, groceries. And the amount is going to be, I don't know, $5. Okay, so let's hit save. And so we've got one entry in our database. Let's add one more. Okay, so we've got two different entries now. You'll notice that I actually had to specify the ID, which is probably a little unusual for you guys because most databases provide you a automatic ID when you insert it into the database. However, DynamoDB, for some reason or another, doesn't do that, and so you're going to see that we're going to have to come up with our own way of generating a unique ID when we insert something into the database. It's just something to keep in mind. I don't know why they decided to go that direction, but that's just the way it is. All right, so we've got our DynamoDB database set up. There's one last thing that we need to do, and that is right now our Lambda functions do not have permissions to access our DynamoDB database. We didn't give them specific permissions to do that. And so let's go ahead and set that up now. And to do that, the first thing that we have to do is we have to get the ARN for this table. And so if you go under overview, scroll down, you can see the Amazon resource name or the ARN for this specific table. So this is just a unique identifier for this specific table. So if we want to make it so that our Lambda functions can access this table, we have to say in our policy that, oh, our Lambda functions have access to this specific ARN. So let's copy this ARN. And then let's go back to our identity and access management tab. And here we'll go back to our rules and let's select our Lambda expense role. And we want to do an add an inline policy. So here, select service, choose a service, and we want DynamoDB. Okay, and at this point, there's a couple of different things we can do. We can just say, allow all DynamoDB actions. So this just will give us complete access to DynamoDB, which would technically work. However, it's not best practice. Generally, when you're working in the cloud, you want to make sure that resources only have access to things that they absolutely need. It's kind of a security vulnerability to give them, access to more things than they don't, because that could potentially lead to some issues down the road. So instead of just allowing all access, let's go in and manually add in each of the specific actions that they should have access to. And let's think about the different actions that our Lambda functions should be able to perform on our DynamoDB database. So the first thing is they need to be able to get an item. And so if you search for get, we can hit add. And then we also need to be able to delete an item. Actually, and we can just search for here. That'll make it a little easier. So here, if we do, we also need to be able to put an item. We'll check that. And we also need to be able to update. And we want update item. And then finally, we should be able to do a scan. This is just kind of like give us all of the entries. So that's kind of the get all equivalent. All right. So we've got all of our permissions in place now. Go under resources here. And under the table, we can actually give it the specific ARN. So it has access to only this table. So copy or remove that and then paste in. Uh-oh, what happened? Closed out. So paste in that ARN that you copied and it should automatically populate all of this info. Just double check to make sure it's all correct. Hit add. And there you go. So our policy is pretty much done. And we can review the policy. We can give this policy a name. So we'll just say access expenses table. All right. And if you do the show one more now, and then do a drop down, you should see the policy that should look exactly like this. So we can get an item, put an item, delete an item, scan, as well as an update item for this specific resource, right? And you'll see that the effect is allow. So when you do allow, it means it can perform these actions. Now that our database has been set up and should be accessible from our Lambda functions, it's time to actually start programming our Lambda functions. And we'll start off by doing the get all because that's the easiest one. So let's go back to the Lambda section. And we're going to go to the get all. And with all of our Lambda functions, we're going to have to import a few things. So the first one, or the main one, is we want to import the AWS SDK. The next thing is we want to specify the specific region. So we can do AWS. So we're just referencing the AWS object that we created. And we'll do .config.update. And then we pass in an object where the first key is going to be region. And that's going to be set to whichever region, all your Lambda functions in DynamoDB databases are stored. So mine's going to be in US East 1. Yours may be in a different location. And then now we have to create our DynamoDB client. So we can do const DynamoDB, and then notice the specific capitalizations I'm using. Just make sure that they match up or they're at least consistent in your code so that you don't technically need to capitalize it the way I'm doing, but I just want to stick to usual camel casing. All right, so now within our handler right here, let's set up a try catch block so that we can try and retrieve the data from our database. And so to retrieve all of the results from that specific table, we can do a DynamoDb.scan. So the scan method is going to give us all of the entries within the table. And we have to pass it some parameters. So I'm going to create an object called params and pass it into here. So we'll do const params equals. And I want you to think about what may be required, right? Because right now, we're not telling DynamoDB, what database we want to scan, what table do we want to scan. So this is all information we need to give it. So I just realized I misspelled params. And really, there's only one property that we need to specify, and that is the table name. So we'll do table name. And we got to set this to the table that we created. So if you already forgot, I'm just going to open this in a new tab. And we'll go back to Dynamo. And just look for the tables that you created. So mine's called expenses too. And so this is going to tell DynamoDB to scan that entire table. And we want to return the results. So we'll do const results equals DynamoDb.scan. And this is technically an asynchronous function. So, we can use the async await, but we have to make one modification. So if we decide to use await, then we have to do a dot promise. So all of the Amazon functions have access to this promise so that we can use the async await syntax. And so here we can do a console.log results. And then down here, I want to do a console.log of error just in case we run into some issues. Let's hit save. Okay, so now how do we test this out? Well, there's this nice test functionality within Lambda function, so we can create a test event. And you'll see that there's a event template. This is the hello world template, so this is a very simple event that we can kind of simulate. And I'm just going to call this a simple event. It doesn't really matter what you call it. This is, I guess we can't use dashes. Call it simple event. You can pass in, like something in the body and things like that. You can just leave that blank for now. We can just hit create. And we're going to run this test and let's just see what the output looks like. And so you'll see this green box right here. So that means it ran successfully and you'll see all of the details. And the info section is the console.logs that we set up. So whatever shows up in the info section is whatever we configured to do a console.log. And so you can see here, we return an object with an items property, which is an array. And then this array is going to store the two different entries within our DynamoDB table. So this worked, guys. Our scan method worked. We were able to retrieve all of the entries within our database. So the next thing we want to do is send that data back to the user, right? So let's go down here. And we've got an example of a response. And so I'm going to copy this from the return response. And I'm going to put it under the try block. And here we can pass in results. And then now we want items, right? Because if we look at the output, right, we want items, which gives us that array. And we can remove this console.log right here. We no longer need that. We'll save this. Okay, and let's test this out with our with Postman. So we want to go to /expenses and do a get. And hopefully this works, guys. And look at that. Let's convert this to JSON. And you can see we got all of the data from our database. So we have finished our first Lambda function. It's now complete. We were able to retrieve data from a database. Okay, so the next Lambda function that we're going to tackle is the getOneLambda function. So let's find that Lambda function on this list. And this one's going to be a little bit trickier because we obviously have to extract the ID from the URL. And it actually took me quite a while to actually figure out how to do that. But that ID is actually going to be stored in the event object. So the first thing that I want to do is just do a console.log for this event object and just take a look at where the ID is going to be stored so that we can extract it. Now, as I stated before, this event object is going to contain all of the information regarding the HTTP request that hit the API gateway. So it should include the ID, it should include the body, and any other data that might get sent along with it. Um, but the problem is that we can't exactly test this the way we tested the previous Lambda function, right? Because last time we just did a test event, and then we created that little test event, which was a simple hello world event, just so that this code would run once and we could see the console.log. However, we need to create a test event that can simulate a specific HTTP request hitting the gateway with a specific ID in the URL. And for us to be able to do that, we have to figure out what that looks like in a working scenario so that we know how to set up the mock or test event. And so to actually see this console.log when we send an actual API request using like Postman, we actually have to go to CloudWatch. So under the monitoring tab. So what I'm going to do is I'm going to uh, send a few requests to the API endpoint. So we'll go to /expenses/ and then pick whatever number. So I'm just going to do 123. And we're going to just hit send. And that should not be a post. That should be a get. So we'll do send. And just click it a few times. Okay. And wait a minute or two because it sometimes takes the logs a little while to kind of sync up. But after you've done that, go into monitoring and make sure you've added the console.log. Go into monitoring, click on view logs in CloudWatch. Okay, and under log streams, select the top log stream. So that's going to be the latest one. And then from all of these logs, we want to go to the ones at the bottom. So we don't want the report. So just keep opening these up until you see one with a large output like this one right here. So this info right here is going to be from the console.log. So this is how we take a look at the console.logs for our Lambda functions when we need to send an actual HTTP request. And so this is what the event object looks like. You can see the route key, the raw path. It's got some other information like the content type, the account ID. It's got a whole bunch of other information, but what we care about is path parameters. So if we select event.pathParameters.id, we're going to be able to extract the ID that the user wants to get. So let's go back here. And now we know how to access that. We need to set up our query to the DynamoDb table so that we can actually get that specific entry. So once again, we're going to have to import the AWS SDK. And we're going to define our region as well. And then let's initialize our DynamoDB client. Right? And just like we did with the getAll method or Lambda function, we're going to do a try catch block. And to get one entry in the table, what we need to do is use the DynamoDb.get. So let's do DynamoDb.get. And once again, we're going to have to pass some params in. And we're going to define that now. So we'll do const params. And just like before, we need to pass in the table name that we're going to search. And this is going to be expenses2 for me. Now, the next thing that we have to pass in is the key, okay? And I don't know if you guys remember this, but if we go back to our DynamoDB table, and if we do a create table, right, we had to provide a partition key. And so we gave this a property of ID. So if we take a look at our database, all of our expenses should have a property of ID, and that's going to be that key that we need to reference. So that's how you uniquely identify an entry within this table. So we do key, and then we have to give it the key name. So it's called ID, right? So we'll do ID. And then we have to give it the ID of the specific entry that we're trying to retrieve. And so we already have that value, right? And that's under event dot, what was it? Path parameters dot ID. So that's going to give us the ID that we want to search for. So all this is saying right here is that under the ID column, we want to find the entry with this specific value. And those are the only two properties that we have to pass into this object. Now we need to store this result someplace. So we'll do const. We can call this expense equals, and then we'll do await. But remember to use the await functionality, we have to do dot promise. And let's just do a console.log of expense and see if that worked. Okay, and I'm going to go back to our DynamoDB. I'm going to find what the ID of one of these entries is. So I'm going to do an ID of 1. And so let's just do 1 here. We'll hit send. It just says getting 1. That's fine because we didn't change the response. But I'm going to hit this a few times just to make sure we can see it in the logs. And let's go back to monitoring and let's see view logs in CloudWatch. Go ahead and select the latest log stream and then go down and then just find one with a larger output that's going to have the console.log. And so this one looks like it has it. But it's printing out a lot of information, and that's because we go back, I think we still have the other console.log. Yeah, we don't want console.log of event anymore. So we'll save that. And we're going to just send this a few more times again. Okay, and so this is the one we want. Notice how there's a pattern, right? So you see the start request ID, then you see kind of like the main body, then we see the end, and then the final report. But we want this middle one right here. And so you can see under info, it's printed out the item. So we get an object with a single property of item, and that's going to have all of the that's going to have the object that's stored in that entry. So you can see the description, the ID, as well as the amount. So if we do, if we go back here, we want to grab expense.item. So let's copy our response and let's move that up into our try block. And what we want to return here is going to be expense.item. And let's save that. And let's test this out real quick. All right, and it looked like it worked. So let's change this to JSON. And yep, you can see the object that we retrieved. And if we go to 2, we should see something different. Yep, perfect, guys. So we've got our get one Lambda function done. The next one we're gonna do is creating an expense. And once again, this one is kind of build up. And once again, this is going to kind of build up on all the things we've learned. This one's going to be a little bit more complicated. Okay, so it's time to move on to creating an expense. And so let's open up our expense-create Lambda function. Now within here, we're going to want to do the same things that we always do, which is import the AWS SDK, set the region, as well as create our DynamoDB client. And so I'm just going to copy and paste that here. All right, and now within our handler, let's set up our try-catch block. And to create an entry, we want to do the DynamoDb.put method. So we'll do DynamoDb.put. And once again, we're going to have to pass in some parameters so that AWS knows what we're trying to create. And this is also going to require a dot promise. So you can do the async await syntax. And we'll do await and store that in a result. So const new expense. Oops, const new expense. And now let's define our parameters. All right, and so the first parameter that we have to pass in is the table name. Then we have to pass in the new item. So we do item, and then we have to pass in all of the different properties. And so we'll start off with interesting fact. Okay, guys. So this is really important. I think I mentioned this earlier on in the video, but DynamoDb does not automatically create an ID for a new entry. So we have to create that either on the front end or within our Lambda function. So for now, I'm just going to hard code some random value like an ID of 3 or 4 or something like that. We'll do ID, and we're going to set that equal to 3. And then our expenses are going to contain 2 other properties. So we're going to have a description. And this one's can be, I don't know, mortgage. And then the amount. All right, so let's do a console.log. And we'll say the new item is, and we'll pass in new expense. All right, so this is just so that we can see what this looks like. Let's hit save. And let's create a test event. So I just want to run this code. We don't actually need to send an HTTP request to the API gateway. And so we'll do test. And I'll just call it whatever you want, really. Oh, it looks like there's an error here. What's wrong? Oh, but I forgot the comma. Okay. So let's test this out. Okay, so it ran. Let's take a look. Nothing got printed out. So here we go. So the new item is, and it just gives us a blank object. So maybe our code doesn't work. So maybe for some reason we didn't actually create a new entry. So let's go to our DynamoDb. Let's hit refresh and see what happens. Okay, so it looks like it did create it. So if we take a look at this, go into text format, you can see it's got the amount that we gave it, the description, as well as the ID. So we did in fact create an entry in their database, but for some reason what it returned was not what we were expecting. And I was actually scratching my head at this when I was first running through this. And if you look at the documentation, this is expected behavior. Unlike most other databases, once again, DynamoDb does not return the newly created item. And so, if you want to return something back to your front end regarding the new item, what you're going to have to do is just basically pass in the item that we passed into the database, which it's not technically what's getting put into the database, but it should be the same, if everything goes accordingly. So you could always just do, you can always do a JSON.stringify and just return this params.item, and that should give you what you need. But we know this code works. The next thing that we need to do is automatically generate a unique ID, because obviously we can't hard code some value, or then every time we run it, it's going to try to put in the same exact ID. It's going to lead to issues. And there's a couple of ways of doing this. We can import the UUID package to generate a unique ID. We can put in some kind of logic to create our own UUID. But I found another method online. I was doing a little searching, and we can actually pass in another parameter, which is the context. And what I want to do here is we're just going to do a console.log of the context. I just want to show you what this looks like. And we're going to change this to a post. And I realized I've got the same ID. That's probably going to create an error. So I'm going to save that, run that one more time. Okay. And let's go to our CloudWatch logs so we can take a look at that console.log. And so right here, this output is going to be that context object. And someone online had pointed out that we can just grab the AWS request ID, which we know is going to be unique for every request, and use that as our ID when we input the new expense into the database. And that's exactly what we're going to do. But once again, this isn't necessarily the perfect solution or the recommended solution. It's up to you to figure out how you want to generate a unique ID. But there's plenty of different examples online that you guys can use to figuring out what method is going to be your preferred method. So I'm going to copy this and let's go back under configuration and under ID. This is going to be set to context dot, and we'll paste that in. Why does this always show up? And it never works. And so this is going to be AWS request ID. Okay, so the next thing is we no longer want to hard code this these two data points in. We want to retrieve this from the body. So we're actually going to pass it in from our front end. So in Postman, if we go to our body, we can select raw and then JSON. We can pass in the data that we want. So here we can change this to electricity bill and change it to 100. And let's hit send. And let's figure out how to actually get that body. So that's going to be somewhere on the event object. So I'm going to do a console.log of the event just so we can see what that looks like. And I know this is a little pain having to go back into CloudWatch, but I'll make a follow-up video on how we can actually test this offline so that we don't have to use, this embedded code editor, which is kind of a pain, and then having to do all of these tests and bounce back and forth within CloudWatch. But let's send a few requests again. And I'm going to go back to CloudWatch and select the latest stream. And we want to go down. Nope. I may have to refresh. Okay, so this is our event object. And if we scroll down to the body, we can see that we do, in fact, receive all of that data in this string format. So we will have to do a JSON.parse so that we can import it in as a plain old JavaScript object and then pass it in as the body. And so this is going to be pretty easy. What we can do is delete this. And we can say const body equals event dot body, and then we want to parse that. So we'll do JSON dot parse event dot body. And then here we can just copy it into the item object. So we can just do the spread operator on body. And that should be it. And what I also want to do is we can also return this item object straight to the user. I'm going to copy this just like we normally do and move that right there. We'll remove the console.log. And this is going to get changed to params.item. All right, so let's hit save. And let's test it out. So we'll hit send. And look at that, guys. It looks like it worked. So it generated an ID. I gave it a description. I gave it the amount, right? And that's all coming from what I gave in the body right here. If we change this to 500 and change this to car payment, hit send, we should see the same thing. Yep. And let's just double check in our DynamoDb table just to make sure everything's working. And yep, we've got a whole bunch of different entries. And we see the last one right here, which is the car payment. All right, so that's it, guys. We've now set up the create Lambda function. In the next video, we're going to tackle update, and then finally we can wrap things up with delete. Okay, guys, so let's tackle the update Lambda function now. And if you forget how the update functionality works, what we need to do is we'll do a put request. And we have to do slash and then the specific ID of the expense that we want to update. So, some random number. And then we also have to give it the description and the amount or the new description amount that we want to update the object with. And so at this point, we can do a send and then it should update that specific entry. So let's go into functions. Let's find our update. And let's import the AWS SDK and set up our region as well as our DynamoDB client. And there's a couple of things that we're going to have to do right out the gate. So we want to get the body from the event object. So we'll do the same thing that we did in the create section. So we'll do const body equals json.parse and then event.body. So we now got the body. And we can set up our try catch block. And to update an entry, we have to do DynamoDb.update. Makes sense, right? Pass it in a params. We want to do the .promise so we can use the async await. And we'll save this to a variable. So let's set up our params. So the first thing is we need the table name. Now we need the key. So this is just like the get one Lambda function. We have to specify the specific ID of the expense we want to update. So we'll do ID, and then remember the ID is going to be stored under event.path parameters.id. And this is where things are going to look a little confusing, but we have to do update expression. I'm going to type out this expression and I'm going to explain to you after I type it out. So we'll do set description equals :d, and then we'll do amount equals :a. Then we want expression attribute values. And we do :d, body.description, and then :a. This is going to be body.amount. All right, so let me explain to you what's happening. So let's take a look at this update expression. And so what we're saying here is that we want to set the description column, right? So if we take a look at our database, right, we've got this description column. So we want to set this description column for whatever entry we're matching here. We want to set the description to :d, and I'll explain what that is in a second. And then we want to set the amount column, that should be an equals, to :a, and that should be a lowercase a. I'm making mistakes all over the place, guys. Okay, so we want to set the description to whatever this is, and then we want to set the amount to whatever this is. And then under expression attribute values, we're setting what these two values are. So :d is going to be set to body.description. So you can see that we've stored the body here, and that's going to come from whatever we send in Postman. And then colon A, which is going to be the amount, we're going to set that to body.amount, which is going to come once again from Postman, and it gets saved right here. So we're basically taking body.description, storing it in colon D, which then gets passed into this expression. So we're setting description to body.description, and we're setting amount to body.amount. This is the way they chose to do it. Once again, I don't know why it is like that, but that's the way. And so that should be all that we have to pass in. However, there's one more thing that we want to pass in, and that is going to be return values. So when you update an entry by default, DynamoDb will not return the newly updated entry. So to actually return it, we do return values, and we do all underscore new. So it's going to return the brand new expense with all of the new changes. And I realize I misspelled const. And it's giving me a warning. Okay, that's fine. And let's just do a console.log of updated expense to see if everything works. And there's a good chance there's a typo somewhere in here. And I'm getting a warning. Params. Oh, here we go. And let me grab an ID that we know exists. So we can grab let's grab 1. And let's set this to, I don't know, 500,000. And we'll say new G6. And we'll hit send. Okay, so we got a response back. It's just saying update expense. Let's hit refresh. And look at that, guys. So you can see the entry with 1, an ID of 1, we updated to 5,000, new G6. So we have successfully updated an entry within our database. However, let's go to our logs and let's take a look at what updated expense looks like. So once again, we got to go all the way to CloudWatch. I know. Very boring. And here we go. So this is the one we want. And you can see there's a property called attributes. And then within there, we get the full object. So we want to grab, going back to our Lambda function, we want to return updated expense dot attributes. So let's take our response and let's move it into there. We can get rid of this console.log. And we can do updated expense dot, what was it? Was it capital A? We can just go back, attributes, yeah, capital A. All right, let's save that. And that should work. So let's take a look. All right, and it looks like it worked. So we've got the new, well, I guess I didn't change anything in this case. So let's actually try changing something. So I'm going to change whatever is stored in 2. And we'll just give it whatever. Get $10. All right, so we got the new data. So we changed the description. The ID is still 2. The amount is 10. And if we go to DynamoDb just to double check, you can see that everything got updated right here. Perfect. That's it, guys. We finished the update functionality. We've got one more Lambda function to finish, and then we're done with this video. All right, guys, we're on to our final Lambda function. This is going to be the delete function. This one's not going to be too bad. So let's open up our delete Lambda function. And let's set up the usual boilerplate. So we're going to import the AWS SDK and create our DynamoDB client. And within here, we're going to do our try catch block. And to delete an entry in the database, we can do a DynamoDb.delete. We're going to have to pass in some parameters, and we'll do a dot promise. And since this is a delete, we don't actually have to store this in a variable. We can just do await and just return nothing essentially. And let's define our params. So as usual, we need the table name. And we're going to do the same key that we normally do as well. So we want to do the ID. And hopefully I made it clear, guys, that, once again, we're grabbing this ID because that's what we gave this field. However, if we called this field something else like a social security number or something, then you'd want to pass that into here and not the word ID. So it's whatever is your partition key, that's what you want to pass in here because that's what ensures each entry is unique. And we can grab the ID from the event.path parameters.id. And that should be it, guys. That's pretty much our entire delete Lambda function. Let's just move our response to here. And this is going to be a 204 because we're deleting an expense. And then, we don't really have to delete anything, although I could say something like, I don't know, status, success or something. All right, let's give that a shot. So we know there's an expense with an ID of 2. So I'm going to hit send. Oh, I forgot to change this to a delete. Okay, and you'll see that we don't get any body here, even though we set the status as success. And I think that's just something to do with the way Postman handles a 204. When it's a 204, it just doesn't, it hides the entire body. So I guess that's just the way it works. But we do get the 204, so it looks like it worked. If we go to DynamoDb, you see the 2 there, but if we hit refresh, we should see it go away. And yep, it got deleted. And just to be safe, let's delete the one with an ID of 1 as well. You see that there's a body here, but since we're sending a delete, we're ignoring the body anyway, so that shouldn't make a difference. Yep, and so there you go. So we deleted that we deleted the expense with an ID of 1. And there you go, guys. We have successfully created a full-blown CRUD application using Lambda functions, API gateway, and DynamoDb. So this is your first introduction into serverless architecture. I'm going to start making a lot more videos on this, especially as I learn it. I'm going to try and teach you guys as well. And so there's definitely much easier ways of developing serverless architectures. This is kind of the slowest and most difficult way of actually developing. There's a lot of tools that we can use to develop offline so that we don't actually have to use the AWS console, and we can debug things and simulate API requests all through our command line and through VS Code. So it should make our lives a lot easier. So if you guys want to see more of those videos, let me know and I'll start pumping those out.